Alright, so let's look at L'Hôpital's rule, or how some people like to call it Hospital's rule. So sometimes it's also known as Bernoulli's rule as well, but I'm going to be calling it L'Hôpital's rule because L'Hôpital published it in his book, but it said that this guy over here, Bernoulli, he founded it, but this guy wrote it first in his book. So I'm going to just leave it there. You can figure that out. Who deserves the credit? But let's get to the formula here. So basically all it's stating is if we have an indeterminate form, right? If we get 0 over 0 or infinity over infinity, right? And, we can't really evaluate the limit like that. That's not really proper for us. If we give that on a test, our teacher won't be too happy with that, correct? So, that's where the L'Hôpital's rule comes in handy here. So basically what we're going to be doing is we're going to be using derivatives to basically figure out these limits that are in indeterminate form. So for our first question over here, we've got, we've limit as x approaches -2. We have x plus 2 over x squared plus 3x plus 2. Yeah, let's go ahead and plug in -2 here. So we can get -2 plus -2 over -2 squared plus 3 times -2 plus 2. What would this give me? Oh no, 0? The bottom is going to be, oh no, we get 0 over 0. Alright, so in that case, we're going to be using L'Hôpital's rule. That's right, we're going to be using L'Hôpital's rule right away. There probably is some other ways to solve this, but let's use L'Hôpital's rule. So first things first, we're going to take the derivative of the top and the bottom, right? So we're going to take the derivative of the top, and this is going to be right down here. Is equal to limit as x approaches -2 from the left of the derivative of my top and the derivative of my bottom. That's basically the only part of L'Hôpital's rule. Take the derivative of the top, derivative of the bottom, and then see what happens when you plug in your number here. So d over dx, and then you would have x squared plus 3x plus 2, and then you would just, all you would do now is take the derivative. So limit as x approaches 2, you'd get, this would basically be 1 over 2x plus 3. Now what we're basically going to do is just plug in our -2 here. So it'll be 1 over 2 times -2 plus 3. So we're going to get an answer of what? 1 over -1. And that's going to be -1. So our answer here is going to be -1. And look how quickly we solved that with L'Hôpital's rule. Isn't that amazing? Here we have e to the power of x minus 1 over x squared plus x, and the limit as x approaches 0. Now let's just straight up plug in 0 here. So it'd be e to the power of 0 minus 1 over, 0 plus 0. So e to the power of 0 is what? 1. 1 minus 1 over 0 is 0 over 0. That is not good. Not good at all, my friends. So what we're going to have to do here is L'Hôpital's rule. Let's do it. So we're going to take the derivative of the top and the bottom. So this would just basically equal, right here, so it looks more neat, is equal to limit as x approaches 0 for the derivative of e to the power of x minus 1 over the derivative of x squared plus x. Alrighty, cool. So now when we take the derivative of both of them, we should be getting, one would go away, of course, according to power rule, but e to the power of x, the derivative of e to the power of x is going to be e to the power of x. So it's going to have e to the power of x just hanging on over there. So it'll be e to the power of x over 2x, right, plus 1. Alright, so that's where this x comes in. And remember, we're just using power rule. Alright, so now we have this. Let's just plug in our 0. We're going to get 0 to the power of, e to the power of 0 over 2 times 0 plus 1. We are basically going to get a value of e to the power of 0 is 1, so it would be 1 over 1. So our answer again here is 1. Alright, look at how easy this question became with L'Hôpital's rule. So this final one is really going to test your determination when it comes to L'Hôpital's rule, right? Because sometimes, we might have to apply this rule multiple times, right, to get our answer.
Sometimes it may be good, sometimes it may be shit.
So sometimes, students are like, why am I not getting the answer? Maybe try applying it again, right? Here, we're going to be working with a trig derivative, and how much we love to work with trig derivatives. Let's go. So we're going to be taking the derivative of everything here first. Let's do it. So it's going to be equal to limit as x approaches 0. We're going to be the derivative of everything here for the first time. I'm not going to write d over dx for everything because it gets really repetitive. Let's just get into it. This is going to be equal to 2 cos x, as we know, simply. Nothing really changes here. You just know that that's how trig derivatives work. It's just standardized. Minus, here we're going to have to use a little bit of chain rule, correct? So it's going to be minus 2 cos 2x, right? And then this is all going to be over, 1, right? Derivative of x is 1, and it'll be minus cos x. Simple as that. And if we, plug in our 0 over here, we'll see that this is still, not going to give us what we need. It's still going to be indeterminate. So we're going to apply the rule again. So this is going to be equal limit as x approaches 0 for, we take the derivative of 2 cos x, which is going to be minus 2 sine x, right? Then you're going to be subtracting from there. I'm going to take, again, it's going to be a form of chain rule, so it's going to be minus 4 sine 2x, and it's going to be over sine x this time. This entire part cancels out. Over sine x. And again, we come to see that, oh no, it's indeterminate, right? So let's apply it again. So it's going to be equal to limit as x approaches 0 for, again, we're taking the derivative of negative 2 sine x, which is just going to be negative 2 cos x, right? And then we're going to look here. Okay, another chain rule again, so it'll be 8 cos 2x. It's going to be all over cos x. And then, now it seems that we can plug in our 0 and we can get some numbers here. Since when we have cos of, let's say, 0, it's just 1. So it's going to be negative 2 plus 8 over a value of 1. So we get our final answer, which is negative 2 plus 8 over 1, which is our answer of 6. And that's it, That's determination, folks. And that may be necessary when we're using L'Hopital's rule. That's it.